depreciation formula is F equals capital I, 1 plus lowercase I to the n. And then depreciation is the exact same thing, but you're going to subtract the interest off. And the reason why it's always a 1 is because 1 is just 100 in decimal form. 1 is just 100% in decimal form. That's all it is. So what this 1 represents is a 1. People are like, what is that? It's a 1. That's all it is. It's a 1. And this just represents 100% of the initial value. Now, if I'm growing, I'm going to add the interest rate to 100%, correct? And there'll be 100 and something percent. Then you know you're growing, correct? And if you're depreciating, it's going to be 1 minus the interest because it's 100% minus what you're decaying by. Okay? So however far you are from 1 is how much you're growing by or you're decaying by. So let's write down what they represent. So F always represents the final amount. So it's what you're left with when you're done doing all of your stuff. If you're growing or you're decaying at the end of year 4 or at the end of year 2 or whatever it may be, that's your final amount. I is your initial amount. It's what you start with. I is your interest rate in decimal form. Not percent. And n is always the number of years. Word problems are a lot easier if you actually understand them than memorize a formula. If you understand why stuff goes where it goes, you will find these really easy. If you memorize by formula, you might mess up because you might memorize your formula correctly. So let's go through and decipher what the heck this one says. So this one is, the initial price of a car is $30,000. What the heck does that mean?
You paid $30,000.
Pay $30,000 right off the bat, right? At time 0, it's $30,000. Well, where does time 0 happen? At our y-intercept. So that's why that goes in the capital I spot. Do you see the I's here? It's because it's your y-intercept. And what's in front when you're in A, B to the N? Your y-intercept. It's your initial value, right? So I'm going to write down my notes. So I know my initial is $30,000. Then it says the value of the car depreciates by 20%. So that's my interest rate, but it has to be in decimal form. So my interest is going to be 0.20. And I know this. So in the bracket, we technically go 1 minus 0.20, correct? But we know that it should be 0.80 because you have 80% of it left, correct? Every single time. That's what that B value represents. How much you have left every single time every year, 80%, 80% of it, 80% of it, 80% of it. So that's why it's 1 minus 0.20 because it's what's left. 80% is left, okay? So sometimes they'll give you the equation and give you like y equals to 0.8 to the x, let's say. If it's 0.8, that means it decreased by 20% because that value is how much is left. Okay? So it depreciates, so I know I have to subtract. If the car is new in 2005, so that's where it starts. It's new in 2005. How much will it be worth in 2010? By saying that, what did they give me?
Number of years.
Number of years. And this is way better than in grade 11, where you have to like subtract and then add 1 and blah, blah, blah. All you do for these is you just want to find the number of years. You just subtract. So we're going to go 2010 minus 2005, and it's 5. Life is so much better in grade 12 when we do these, because these come up in exponentials in grade 11, and it's not nearly as nice. Because you have to add 1, because they have an n minus 1, and blah, blah, blah. What are they making us find? What are they making us find? Final. Just like in physics or in chemistry, you can only have one unknown variable, correct? So as long as you have one unknown variable, you're golden. This one, actually, the unknown is the easiest one, because it's the one by itself. So F equals initial, which is 30,000. And then this is to the 5. Now, should my final be bigger than 30,000 or smaller? Smaller, because it's depreciating by 20% every year. So I have 80% of the original every single year, correct? That's what it's getting me. So it should be smaller. So this is technically 30,000, bracket 0.8 to the 5. Type it into your calculator. what do we get? 0 decimal? Are you making it go 30,000.8 to the 5?
Oh, okay, that's right. I forgot to do it.
What do you get?
9,830.4.
30.
That took me a second.
0.40?
Yeah,
Does that seem realistic? Does that seem realistic? Every year I'm losing 80% of it.
Well, I mean, it depends on the miles, the engine.
We're not talking real life situations here. We're doing ourselves like a genuine thing here. So at 30,000 we lose 0.8, and then we're down at that value, then we lose 0.8 of that, and then we lose 0.8 of that, and 0.8 of that, and 0.8 of that, and then we have an answer, right? Because it's after 5 years. So $9,830.40 does seem realistic. Okay, the next one says, how long will it take to the nearest tenth of a year for this car to be worth half of its original value? What did it give me? Well, it wants n. I can tell that because it's long. How long? What did it give me? Yeah.
The new initial.
New final?
Or final is.
Yeah. Yeah. So the final has to be worth half the original. So if we go 30,000 and we divide by 2, we get 15,000. Our initial will never change because that's how much it cost us to get it. And it's still depreciating by 20%, correct? So we're going to have our final, which is 15,000. Our initial is 30,000. Bracket 1 minus 0.20 to the n. Now, I'm going to tell you one thing. If you do this every single time, your life will be made easier. Okay? What you need to do is you need to always divide your initial over. Do that first. Because if not, you have really large numbers currently, don't you? You have 30,000 and 15,000. Those are some really large numbers. And we're going to solve these with our calculator till next week when we have to learn how to solve it algebraically. But our very first thing we're going to do is we're going to actually divide the 30,000 over. If we have final and initial, if we have both, our very first step is to divide this over. You cannot make the 30,000 join the 0.8. You cannot multiply those together or bad things will happen. Bad things will happen in that you're going to get the wrong answer and it will be there because that's common error. So instead of taking the 30,000 and multiplying by the 0.8, which is illegal, you have to divide it over. So now we get 0.5 equals 0.80 to the n. And we're only going to solve algebraically today. We're learning how to solve, graphically today. We're learning how to solve algebraically in next week. So here, this is going to be my y1. This can be my y2. Whenever you want to solve, you can always actually solve. As long as there's only one variable, you can always solve with your calculator. However, if they say algebraically and you solve with your calculator, you're going to get 0 marks. Okay? We know that our answer, we're going to have to find it out, is a number of years. And they want to the nearest tenth. So we're going to go 0.5 into our y1. Everyone's doing this. Into your y1 of your calculator, you're going to go 0.5. And into your y2, you're going to go 0.89. I don't have my calculator. We're going to go 0.5. And then we're going to go 0.8 to the n, or x. And we press graph. Now, keep in mind that your calculator can only find intersections where it can see them. So if you go second trace 5, enter, 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 and it's like error, and it gets mad at you, you need to make your x max or x min bigger. Often it's not your y's, but you have to be able to, often it's just your x's. So this time I can see where they cross, so I go second trace 5, enter, 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 and it's 3.1. I think that's a 0. Is that a 0? Yeah. Yeah. So it's 3.1 years. So you just go second, trace 5, enter, enter, enter. Now in any solving, even in trig, you could have done this. You could do left side into one, right side into the other, and you just get more crossing points than just one, right? And you have to find all the intersections. So whenever it's solved, it doesn't matter what unit you're in. If it says solve, you can go y1, y2, and find where they intersect. However, if it says algebraically, and you just give the answer like this, you'd get 0 marks. Okay? So, I think it was 3.1 years. And if this is a diploma or a test, you write a sentence. So you would say, it takes 3.1 years for the car to be worth half of its original value. You basically restate the question, right? That's all you do. So, example 2. The population of a city was 250,000 on January 1st, 2000. Now that could be final or initial. We're not sure. We have to keep reading to figure out if that's where we started or if that's where we ended. So it says population of a city was 250,000 on January 1st, 2000, and it was 310 on January 1st, 2008. So which one is my initial?
250,000.
Right, because it happens in 2000, and the other one's 2008, which is later, right? So my initial is 250,000. My final is 310,000. What else did that give me?
Years.
Years. What's it going to be?
8.
8, yeah. 2008 minus 2000. If the growth rate of the city can be modeled by an exponential growth function, the average annual rate of the population of the city, growth rate of the population of the city to the nearest tenth of a percent is what? So what are they making us find? Yeah, the interest, the little I. So we have final, which is 310,000, equals initial, which is 250,000, bracket 1 plus, and it's growth, so I use plus, correct? I to the 8. And it has to be plus. And also this, if it's a growth, think about this, your initial needs to be a smaller number than your final, correct? Some people will swap them and then their calculator gets mad at them and they're like, it doesn't work. And it's because your initial is bigger than your final and you're growing, which doesn't make any sense, right? My initial needs to be smaller than my final. What do I always have to do first when I had final and initial? Yeah, divide. And 310 divided by 250,000.
1.24.
Is that rounded?
That's not something.
Okay. If it's rounded, if your decimal keeps going, you can't write the decimal. You have to write the fraction, right? You can't round ever before your final. Ever. That's in math in real life all the time. You can only round before you're at your very last step, correct? So I'm allowed to use 1.24 because it actually stops. But if it was a number that just kept going, I'd have to use the fraction in my y1. Does that make sense? You cannot round until the very last step. So you get 1.24, and then you get 1 plus I to the 8. And now we're going to y1, y2 it. $1.24, and then it was 1 plus I, which I'm just going to use an x, to the 8. And then I press graph. Now there's going to be 2 answers here. One doesn't make any sense because it's a negative interest rate. So don't find that one. So second, trace 5. I need to be over here where the positive one is. And it should be a teeny tiny decimal. Why should it be a teeny tiny decimal? Yeah.
Because it's close to the wall.
Yeah, it's close to the y-axis, and it's an interest rate in decimal form, right? If it's like 3.7, that's 370. Like, that doesn't make sense, right? It needs to be a number between 0 and 1. So this one is 0.027 to 0.0272, etc. But that can't be our answer because it wants the growth rate to the nearest tenth of a percent. So what do I have to do to that? Yeah, make it a percent, multiply by 100. And my interest rate is 2.7%. And once again, if this is a word problem or on a test or on a diploma, you're going to write the average annual growth rate of the population of the city is 2.7% from January 1st, 2000 to January 1st, 2008. Okay? You guys try example 3. Okay, this one says, in 2002, the population of the city was 160,000. Then it asks for 2005. So I know that this is my initial. And it's increasing at an interest rate of 4.5. I should have a percent symbol, sorry. So 0.045. is what you're going to fill in, because you always have to have it in decimal form. Now here it says write an equation to represent the population P, so Y actually has to be P, of the city in the number of years N. So we actually only fill in the capital I and the I for this. So it's going to be P equals, and you can't use Y because they told you P is the population. And then 160,000 bracket 1 plus 0.045 to the N. And they'll put that together. So they're going to go 160,000 bracket 1.045 to the N. So they sometimes just want an equation set up, right? They don't want you to solve anything. They don't like look for extra stuff. And then this one wants it in the population in 2005. So what do I have to do? Yeah.
Subtract 2002 to 2005 to get the difference and then plug that into the end.
Yeah, so 2005 minus 2002, get the difference, which is 3 years, and plug that in for N. So I go 160,000, 1.045. Now question, should this number be bigger? Should the population be bigger, or should the population be smaller than 160,000?
Bigger.
It should be bigger because it's growing, which is why I did 1 plus, right? Now it's a population, it's a person. You need a whole person, just so you know, just in case you were wondering. You do.
We can cut the
Still a whole person, just missing limbs. Yep, where you're going with that one. All right, so we have 182,586.58. We actually always have to round down because it's a human. You can't find a 0.42 of a human somewhere and then just make it be a big human. It's like cows. It's like trying to fit a cow into a horse trailer, and you can fit 7.9 cows into the horse trailer. You can't put 8 because the door wouldn't close and they would all fall out and they would be dead. See? Vicious. That's how it is. So if it was 7.9 horses that could fit as well, only 7 could fit. You can't let the door wouldn't close and they'd be dead. That's what would happen. Same thing here with population. It's going to be 182,586 whole people. All right? Then we're going to flip over. Oh, you have a C. My C's on it. It does this. I don't know why. We don't follow the same. I print it and it does crap like this. Anyways, here's your C. So C says, if the population continues to grow at this rate, determine the number of years to the nearest year for the population to double. So how many was there? What was your population? 160,000 was the initial. What's the final going to be now?
32.
Yeah, 320,000. And I still have 1.045 to the N. Now they want to know N. To the nearest year. So we needed to double, so we're going to have to go first, always divide our initial over, which makes it be 2 equals 1.045 to the N. And then how can we only do this now? Y1, Y2. That's all you got. You have no more tools in your tool belt right now to do anything more than that. Y1, Y2. So typing it into your calculator. In Y1 you have 2, and in Y2 you have 1.045 to the X.
That is a weird thing.
Yours is a weird thing right now.
Yeah, like I can't start on this.
Did you use an X? Did you use the power of X? Did you put an X beside it? Okay, one second. So I just want to show you something. It's going to say no sign change if you use a standard window. Why? What does no sign change mean? That just means, hello guys, I can't see the intersection. That's literally, it should speak in like our lingo. Like it shouldn't be like, error, no sign change. It should say, you suck and so does your window. I can't see the intersection. Change your window. Like, wouldn't that be nice? Then you'd be like, oh, right. I'd even let it cut me down if it told me how to fix the problems. So all that means is on your standard window, you have a calculator that looks like this on a standard window. Right? But it's crossing. Here's your window. It's crossing somewhere here. So what's the only thing I need to change? My X max. I don't need to make all of them a million. Like, don't go, oh, okay, well, then X min is negative 3,000, X max 3,000. That's not helpful, okay? You need to see over here, which is your X max. Don't change anything else. Everything else is fine. So I go to my window and make my X max be 20, let's say. Now try it out, but just your X max. And now I can see it crossing. So second, trace, 5, enter, 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 and it gives me 15.7,
Nearest.
which is 16.
I don't know what to do. What the?
I want you to try example 4 on your own, and if you're struggling with your calculator. So this one here says the number of fish in a lake is decreasing, so we know we're going to have to use I at 0.05, but we're going to have to minus. Yep. And it wants us to write an equation. Now this is giving us variables, so we have to use them. Write an equation to represent the number of fish present in T years. Years is always our X. NO represents the initial population, so my capital I is N little o. And NT represents the final population, so my capital F is N of T. And then we fill in T, N is T. It's all variables. Okay, so we're going to do N of T equals N of O, NO, not N of O. And then 1 minus 0.05 to the T. So it's N of T equals N of O, that's not of, whatever, subscript, 0.95 to the T. Then it says, if there were 2,500, I don't know where I was going with that, fish present in January 2000, how many do you expect in 2005? So N is 5 this time, which is T. T is 5, technically. And then your initial, your NO is technically 2,500. So we have to find N of 5, because we can fill in for T this time. See, look, function notation, it's back. 2,500, 0.95 to the 5. So that gives us 2,500 bracket 0.95. 1,934 fish. So you'd write a sentence. How many would you expect to be present in January 2005? There would be, I would expect 9,300. No, oh my gosh, 1,900. Same boat. 34 fish present in January 2005. Then it says, how many years to the nearest tenth would the fish population to reduce to half? Okay, would it take, I can't speak. I'm just going to fill in numbers. 1,250 equals 2,500. 0.95 to the T. Divide by 2,500. Always divide your initial over. And you get 0.5 equals 0.95 to the T. 0.5 and 0.95 to the X. T equals 13.5, which is that, years, because that's near 10. Now your homework this weekend is, I'm not giving you anything on this, your homework this weekend is, I know you were studying trig and then you just let logs and exponentials fall, and you don't even pay attention to them, and you probably don't remember I taught you. So your homework is to go back and look at the lessons that were taught. So we did exponential graphs, we did solving by common base, we did transformations of exponential graphs, and we did this word problem. You need to know all that stuff, like the horizontal asymptotes and the domain and range of those, right? You need to know all that stuff really, really, really well when you come on Monday.
Are you ready?
Okay?